Hello and welcome to Pet Talk with me, Anna. And are you going to do this or are you going to lie down? Okay, that's fine. You are going to do this. Okay then. So it's Pet Talk with me, Anna, and Teddy. Well done, fantastic. And we are welcoming our wonderful guest today, who is Carol Hughes. Hello, Carol.
Thank you, Teddy. Thank you for the introduction. That's very cool.
He's very, very good at introductions. He's brilliant.
Yes,
He
it
doesn't do
is.
goodbyes.
No,
And
okay.
I think that this is a dog thing. They like to do hellos.
Yes, yeah, yeah. My dog likes to do hellos too, but not quite as well as him. That's very well practiced. Oh dear.
Oh, well, Teddy, are you ready to do some amazing learning today? What do you
Yeah,
think? You ready? We're going to be talking about your microbiome.
yeah,
Well,
yeah.
he's sat down. He's all ears now.
Oh, that's great. That's really good. I'm not really sure where to start. It's such a massive story, isn't it? That's the thing.
It is. So, before we launch into the actual subject, we best tell our audience what you do because you are involved with something called equibiome,
Yes.
which is about horses. So, tell us about that side of things. What
Okay.
do you do with equibiome?
Yeah, well, we started Equibiome in, I think it's 2018, but we'd been researching the microbiome of horses and dogs. We just seem to do the two together since 2014. We started, it was a bit of a disappointment when we started because we were looking at drug discovery from plants. So we were taking active plant compounds out of native plants. We were looking at wild spinach. That was one of our kind of real focus plants. And then we were extracting steroids from it actually at the time. And we were looking, and also antibiotic uh, kind of active substances from the plant. So it would go on to make a novel antibiotic. And we were doing that with the three universities of Wales because there was a lot of funding at the time to try and make a sustainable future. I think we're still into sustainable futures, but it needs a lot of money and a lot of support. And I don't think there's much government money going into it as much as there was in 2014, which is interesting. So the idea was that this plant would be grown under certain conditions that would make it make more of whatever compound you wanted to produce. So there was a huge interest and huge support from the Welsh universities, including Cardiff, that make medicine. So anyway, we got to second stage research of where we needed to put animals in cages to actually prove that the compound we were using would pass over the gut wall and make it into the inside of the animal, kind of thing. If it would go over the gut wall and get into the bloodstream, and we kind of went, well, we don't want to put dogs in cages. That's a no-brainer. So it kind of stopped there. And we'd done second stage with Butcher's Pet Care, and we'd also done it with equine. We'd been doing work in Newmarket with it. But at the point where it was dogs in cages, we thought that was the end of it. We thought, oh, God, we've worked so hard, come so far, but this is the end. And then we met with the team at Aberystwyth, and they said, no, no, the future of this kind of thing is to look at the microbiome and see what happens when you put this stuff in. We've got these amazing tools and technology and genomic sequencing, so we'll do that for you. So we had 4 years with them. Um, and as I say, I was quite disappointed because I couldn't get my head around why that would work, because I'd always been, the gold standard was, will it get over the gut wall? So the fact that it didn't need to get over the gut wall took a long time to get my head around. But in the end, I was absolutely astonished. So 4 years later, we'd gone off in a different direction, but a much better direction. And we've just continued down that route ever since.
It's kind of surprising in a sense that you're talking about looking for an antibiotic.
Yeah.
And yet we're talking about the microbiome, and the two don't always dance well together.
So, yes, no, antibiotics and the microbiome don't work well, but we have a concept of an antibiotic being something you make in a lab and then you give to people. Well, the microbiome makes its own antibiotics. So it's really learning about what that means. An antibiotic is actually an antimicrobial, so it acts on microbes, and the microbiome makes them all the time. So it's learning a different process, how the microbiome makes its own antimicrobials to balance and help restore health without us having to kind of invade it so much or interfere with it so much. It's a very balanced, kind of ecosystem. It's very balanced and it's very logical, actually.
That's brilliant, because really what you're talking about is that we need to understand
Yeah,
something that is natural better and then work with it rather
yeah,
than trying to control, manipulate, etc. So
yeah,
so that's quite a fascinating history of how you got to where you've got, and it seems
yeah,
that you have learned a lot along the way.
yeah,
So if we're looking at a dog's microbiome, how does that differ from people's? How is it very similar? What are we looking at here?
yeah. Well, when we started in 2018, I think with the dog microbiome, because the tools are so accurate and they can identify all these bacteria, we were actually quite shocked at the amount of pathogens and the potential for infection that was in a dog. And we were quite sort of wary of getting involved because these dogs were quite healthy. So, we couldn't actually say, oh my God, your dog's full of Campylobacter. It would frighten the person a lot because obviously Campylobacter isn't a very nice bacteria. So we had to learn quite quickly why the dog had Campylobacter, what that was about. Was it a bad thing necessarily, or where did it have a place in the microbiome? So very early on, we weren't into killing off bacteria. We kind of took the route, well, everything in the microbiome has a reason for being there. Let's learn what that means. So for the dog, it meant accepting that bad bacteria weren't always bad, which means we are out of sync with most of the veterinary profession, sadly.
That makes sense to me. We're we're so prone to labeling good, bad, but as
Yeah,
I've been learning myself about the human gut microbiome,
yeah,
I've been understanding that it's less about good bacteria and bad bacteria, and
yeah,
more about having a balance in
yeah,
the gut microbiome where everything plays a part, but
yes,
it's very finely tuned. And what we don't want is for something that is more aggressive to be
yeah,
taking over. Uh,
okay,
and
yeah,
that's like a garden, where we've got some plants that are much more aggressive and
yeah,
dominant and will prevent others from thriving. And we need to keep that balance. So
yeah,
it's very interesting that you're kind of coming to that awareness within the dogs as well.
yeah. But then we had what changed everything. We had COVID, and during the lockdown period, I think was it 2021? I think just trying to think, it seems such a long time
Uh,
ago.
The 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 harsh one was 2020,
Yes,
and then
2020 then.
they tried to keep it through 2021, and then realized that actually, there were government officials who were not observing it, and perhaps it wasn't a good idea to
Oh,
impose it
right.
on everybody.
Well, in 2021, the microbiome of the dog changed overnight, and it was such a shock because at the time we had an automated report writing process, and the report didn't work anymore. So whatever we want, whatever we felt were the average levels that we'd worked out since 2014 actually didn't work at all. And the report would spit out just something completely bonkers, like the dog has nothing but Prevotella in the microbiome. So there was clearly a takeover bid. Sorry, there's clearly a takeover bid of one set of bacteria. So we kind of alerted the vet. Well, first of all, we had to alert the vets that we were working with because it was mostly vets. And we then did a trial looking at what this was about. We never got to the bottom of it, except that the inflammation in the microbiome increased, as did the anxiety and the reactivity, because this particular bacteria was so dominant and it stimulated the gut brain axis so much. I mean, it was a real kind of I don't know, it was an explosion, I suppose, in the microbiome. And then later, we did discover that patients with COVID, there's actually a headline, and I will find it for you. It's quite frightening, but they basically worked out that Prevotella, this bacteria, was actually amplifying the virus or whatever it was at the time. It was somehow linked to this bacteria that had taken over in the dog microbiome.
So are you saying that during this period of high stress for
Yeah,
families, in which many dogs were not getting the walks that they were used to, and in which we had it seemed, I seemed to remember reading at the time that behavior in many dogs was getting difficult,
yeah.
that coincides with a year later their gut microbiome showing signs of an increase in a particular bacteria, so an imbalance in the microbiome.
Yes, exactly that. And at the same time, the um, the bad bacteria, the Campylobacter, all those ones that were the bad guys that we'd learned to love because they stimulated the immune system, they all got kicked out of the microbiome, and we've never had those come back.
Wow. Okay, that's quite huge, isn't it?
Yeah.
Because there's so much in there. There is, and there's so many questions. For instance, what is it that tipped the balance? Was it the stress levels? Was it
Yeah.
the decrease in outside walks? Um, and then why has it not returned to normal? That's a very interesting discovery there. And
Is
behavior as
that
well.
I think with it, with the Prevotella, we kind of felt because it was antibiotic resistant that it may have been the increase in antibiotics during COVID. So we pursued that as much as anything, that antibiotic resistance in the gut and in the bacteria that are left in the gut has risen massively. So the gut is now a reservoir for antibiotic resistant bacteria, and it wasn't in 2014.
Wow, that is extraordinary.
Yeah,
And it again it fills me with so many questions. So I have not noticed any difference in Teddy in terms of his behavior.
yeah,
I haven't noticed any change in his health. He has had allergies since he was about one.
yeah,
And what I would say is that where we had managed his allergies through diet up until about 2 years ago without any issues, there does seem to be a slight return of the allergies.
yeah.
And and that is very interesting because we haven't taken any antibiotics,
No,
and he has had to have, but he has had to have antibiotic eardrops
Yeah.
because of an ear infection due to the allergies.
Yeah. So I think it's astonishing where we're at. Um, but it's what we do about it, I guess, isn't it? For a lot of dogs,
Yeah.
we are starting with fecal matter transplants. I found, because there is a formula for the microbiome to be resilient and stable, you need to have 24 species. So if a dog has 650 species, 24 of those have to be above 1%. That's it. So you think of all those species you've got hundreds and hundreds, you only need 24 to be above 1% to stabilize it. But those 24 species have to make up 55% of the microbiome in total. Now, with a dog that has high Prevotella or antibiotic resistant bacteria, you have 16 species above 1%, but the top 16 species add up to 78% of the microbiome or higher, maybe 80% of the microbiome. So it means the top two species are very high. So they could be 30%. You could have two species that are 30% of the whole microbiome each. So you've got two species making up 60% of the microbiome. And if they produce toxins, if those two bacteria that have taken over produce toxins, then you're going to have things like itching and things like reactivity because the whole microbiome is wired to be dysfunctional. There isn't anything helping it to function properly. It can't digest food. It can't have make the chemicals of calmness or serenity. Everything goes bonkers around this toxins that the microbiome is producing.
You talked about reactivity, which obviously means heightened sensitivity.
Yeah, yeah. Because when the it's like because the microbiome is logical, because Prevotella belong to Bacteroidetes, which are inflammatory. When they go up, the firmicutes, the one that's the good gang, they go down naturally. So it doesn't matter you talking about, well, I'll give probiotics to support the good gut bacteria. You can't because the Bacteroidetes are at 70 or 80%. Well, no probiotic, I don't know what dose you would give, but milligrams a day can take over, this aggressive antibiotic resistant gang of bacteria that are there at 78%.
Okay, that's quite something. And but I think we've kind of um, skated around something that is huge. So when we're talking about human antibiotics or humans being on antibiotics affecting
Yeah,
the dogs,
yeah,
I think that bears some explanation because what we're saying is that if we're sharing a home, we're sharing a microbiome,
yeah. No,
which,
you are. You
which
are.
means that our dogs either benefit or suffer from anything we do that affects our microbiome
Yeah,
and potentially vice versa.
big time. Big time. Yeah,
Because we know that that within households, people will share a microbiome. So
yeah,
humans will share a microbiome.
yeah,
But it's the same thing now when we add animals into the picture. Dogs,
yeah,
cats, I presume, would be the same. So that's
yeah.
a very important thing. And it's not a bad thing. In fact,
No,
I was only just recently reading that from the point of view of immunity, stronger immunity, having a dog in the house or a cat in the house is a good thing because
yeah,
it strengthens our own microbiome. So this is generally not a bad thing. It's when we start bringing in things which badly affect the microbiome. And what I'm gathering from this is that their microbiomes are actually very sensitive to
very.
to um, chemical stuff that we're putting into our bodies.
Yeah, very. I would say the dog is more sensitive than the human, for sure. More sensitive than the horse, and definitely more sensitive than the cat. The cat takes after the soil, and the dog takes after the human.
Ha, I love that. That makes a lot of sense, actually, when you think about the intimacy of the relationship between dogs and humans. And I know, having lived with three cats at different points in my life, how intimate that relationship was. And yet there's something different
Yeah,
about a human dog relationship, which is hugely intimate, um, in a way that it's hard to say this because I was so close to my cats and my cats were
yeah,
so close to me. But there's something different about Teddy that I can't put my finger on. And it comes from his species. And now you're telling me this, and it's wow, that's huge, absolutely
yeah.
huge. Uh,
I, also a dog is if he's not if his microbiome isn't stable, will pick up on a horse and will pick up the bacteria that cause it's spirochetes, so it causes acidosis in the dog. And we had one this time. I mean, we don't get too many dogs that live with horses. I know you probably know lots of people, and I do, but the people that use the test generally aren't horse owners. But we have some dogs that are in such a state of distress for one reason and another and have been that way all their life. So it's not really COVID. Something's happened in their past. But they then pick up on the horse, and the horse brings something called spirochetes, which belong to the syphilis family. And for a horse, they're sort of okay. Well, they're not okay at really high numbers because they cause acidosis. But in the dog, they cause extreme gastric discomfort. But it's so unusual for a dog to go out and do that, almost seek out the horse and populate its gut with these bacteria that cause acidosis. And we're seeing more dogs like that. And I don't really know, unless it's because their microbiomes are not resilient and it's just accidental that the horse bacteria get into the gut of the dog. But that's particularly distressing and difficult to sort out.
so my mind is kind of reeling here as I
Ah, sorry.
understand. No, no, it's
Mm,
wonderful. The level of sensitivity that our dogs have in
yes.
systems. And I'm now thinking about the way in which most dogs are bombarded
Yeah.
with chemicals, not just because of what we're putting into our bodies, but because of uh, chemicals in the home. And,
Yeah.
and if that's not enough, the flea treatments, the worming treatments,
Yeah.
the vaccines that are given to them
Yeah.
at very young age when they're you would think that the colostrum of the mother would still be protecting them.
Yeah.
And I'm questioning all of this as I'm listening to you now.
Yeah. I mean, I think for the dog, he has a very high need to scavenge. And I think it's driven from the gut through the gut brain axis. Because we do a lot of wild dogs and they can digest nutrients from an old boot. Their guts are so amazing at finding and looking for items that they can digest in some way. The wolf, a wild wolf that's never ever had human contact, is similar to a wild dog. And they just have this incredible ability to search out food. Well, I think the domesticated dog has a need to do that too. I've got my own two dogs, and we live on 25 acres of wild Welsh Hill, and they have real desires about what they need to eat and what they need to find. And I don't mind what they do because it's quite clean here. But if you put a dog in a city, let's say, or a less than ideal place where they can't scavenge stuff out, they're going to find other ways to fulfill that desire. And I don't think that's great for them. And I think that's the seeking out of the horse poo or becoming close to a horse. I don't know why they need to do it, but they do, and I don't think we're fulfilling what their desires, their drives, as much as we probably did 30, 40 years ago. I mean, 30, 40 years ago, they'd have a bone, bury it. Mine still do. Dig it up 6 weeks later, and it would be revolting, but they'd eat it, and that would be fine. And I think that's part of what makes them a dog. And I don't know how you get that back because we've not got the bacteria in the gut that can support that at the moment. So it's very difficult.
So, what you're saying is we are separating our dogs from nature.
Yes.
And at the same time, as I've said, we've got this bombardment,
Yes. Yeah.
which are not helpful
No.
ultimately to their good health. And the truth of the matter is that we are seeing the longevity of dogs decreasing.
Yeah.
So the life expectancy of dogs is going down. And
Yeah.
if we're scratching our heads asking why, I think the answer actually is pretty obvious. It's because the lives that they're leading, however loving and well-meaning we might be,
Yeah.
are too artificial. The
Yeah.
food that most dogs eat is very artificial. So
Yeah.
they're highly processed. And maybe, there's an argument in what you're saying for a raw diet. Uh,
Yeah.
and
Yeah.
and I think it's made me think about something that I read last year, and I'm just trying to recall it. But it was a book about traditional culinary traditions.
Yeah.
It was about culinary traditions and the how moving away from those culinary traditions has landed us in a rather big health mess for the human side of the equation.
Okay.
But one of the things that they talked about was studies that had been done where they were still looking at indigenous populations that were not really, that were kind of separate from our westernized way of being,
Yeah.
and how very often they would eat the stomach of an animal that was hunted, etc., and the contents, because the
Yeah.
contents were fermented and there were bacteria in it.
Yeah.
And the thing that made me immediately want to translate to eat, feeding Teddy at least some raw food,
Yeah.
was discovering that we're meant to have some raw meat in our diets because of the enzymes that are there. And
Yeah.
there are lots of culinary traditions. In just about every culinary tradition, there's at least one recipe for
Yeah.
raw food, whether it's sushi or carpaccio, or
Yeah.
that
Yeah.
it's
Yeah.
in there as part of our diets. And so I immediately thought, okay, hang on a minute. I have a dog here that has allergies. I think I'm going to go and feed him some raw food uh,
Yeah.
because he's
Yeah.
missing these enzymes. Right. We've outlined the problem,
Yeah.
and you're talking about fecal transplants,
Yeah.
which I imagine are costly.
No. No.
No,
No.
that's the good news.
We're doing them dried, so it's fecal mass transplants, but they're freeze dried into tablets or capsules, so you can take them orally. And there are two companies that have done quite a lot of Animal Biome in America is one, and I think there's Legacy Biome in Canada. But the way we're doing it, so we know that the gut bacteria get through. I'm not someone who thinks that the gastric acid destroys the bacteria, because some of these bacteria are wicked and will get through anything. They'll get through, sort of lava, bottom of the ocean, freezing, anything you throw at them, they will
Tough,
survive.
tough little critters.
Otherwise, we'd be in trouble, wouldn't we? So it's just a pill. So you take it every day, 1 gram every day, and it repopulates the gut. It adds 30% extra bacteria to the gut, which is phenomenal, really. But the downside is we've found only one donor out of 2,000 plus dogs that we had as potential donors. we only have one that is resilient enough and will pass on that bacteria to the dog. So you can see how unusual it is to have a dog with a good microbiome that is resilient enough to be able to help other dogs. I think we're in such a crisis. It's a tipping point, isn't it, really? We either get it right now or we're just going to struggle with poor health in dogs.
One last question, because I think that what you just said is amazing, and I am definitely going to look into this to ensure that Teddy has the happiest microbiome that we can help him have.
Yeah,
Um, but it's the question is to do with allergies, because there seems to be a higher and higher incidence of allergies amongst dogs.
yeah,
And I think it might be good for you to explain the link between allergies and the gut microbiome.
yeah. Well, I think there are multiple links. It's not just one link. I think one of the links is as the bacteroidetes, the antibiotic resistant bacteria, those that are inflammatory and have a bit of a dodgy relationship with the host, they can be good or they can be bad. I think as they increase, which they will do at the moment, because post COVID, that was the trigger. Whatever it was, I've no idea, but that was the trigger. So that's a trait that we're seeing, or a tendency we're seeing. As they increase, the bacteria that help the immune system produce stuff to like food sensitivities, allergies, yeasty ears, all that itchy, scratchy skin, they decrease naturally. So they do not like the atmosphere that the bacteroidetes set up in the microbiome. They've taken over the garden, if you like, and there's no room for the flowers because the weeds have gone mad and they're stronger, and that's where you're at. So you have to get rid of the weeds, and then the flowers can come back, help the flowers to come back, feed them, sort out the soil, and then the immune system will work as it should do. So that's one very common strong link we see at the moment.
Wow, that is absolutely brilliant. I love the work that you're doing, and there's so many things that have come up in this conversation, not least the behavior of dogs.
Yeah,
And you have to wonder how many dogs are being labeled as bad because they're reactive. And we know that there's a correlation sometimes between reactivity and pain. But
yeah,
and we also know that a lot of inflammatory things, like even arthritis, etc., are inflammatory illnesses that chronic illnesses that come from the gut as well.
yeah,
So
yeah.
it's such a big area, and um, I'm so grateful for the work that you're doing.
I
Thank you.
know. I
And
think it's just a great area to be in, isn't it? I mean, it's totally fascinating. We've got some really good tools for doing it.
yeah, it's wonderful, and I am eagerly looking, to learn more as you progress with your research. So, if people want to find out more about what you do, Carol, how do they find you?
Our websites are biomeforpets.com or equibiome.org.
Wonderful. I'll put a link to both in the description box.
Yeah, no, brilliant.
Thank
Thank
you.
you.
Thank you so much for your time today.
Yeah, no, thank you for talking. Yeah, thank you very much. Thank you for having me. Thank you.
And thank you all for watching. In the description box, alongside the websites that Carol has mentioned, you will find a link to my Substack, in which I am now writing the adventures of Mummy and Teddy. I'm sure that they will make you smile. Until next time, goodbye.